Hello everyone, welcome back. Today we're going to do a second example of finding the distance from a point to a line. So recall from the last video that we talked about how the distance from a point to a line is always the shortest distance from the point to the line, right? Because there could be many distances if we take a detour from point A to point B, but this is going to be about the shortest distance. Now, the shortest distance means we are going to go from whatever point we're at to the line at a 90-degree angle. That is going to give us the shortest distance. At going at it at any other angle will give us a longer distance than we actually had to travel. So the very first thing we're going to do here is we are going to find a line that passes through the point -6, 2, and that is perpendicular to this line. So let's do that. So step one is to find a line that is perpendicular to y equals -x plus 4 and passes through -6, 2. Okay, so let's do that first. So first of all, what is the slope of this line? The slope of this line is going to be it's going to be 1. And how do I know that? Well, whenever we are taking the perpendicular slope, we always take the negative reciprocal of the original slope. So the original slope in this case is -1, right? Because here we have -x. The negative represents -1 because there's no number with it, right? It's like -1 times x. If we take the reciprocal of 1, we just get 1 back. If we apply a negative to an already negative number like -1, we get +1, right? Recall that -1 is +1. Therefore, our slope of the perpendicular line is 1. And then the point we're trying to pass through is x equals -6, x equals, and y equals 2. And so therefore, y is equal to 1x plus b. And then let's plug in x and y. 2 is equal to 1 times -6 plus b. Therefore, b is equal to 8. So the equation of our line is y equals x plus 8. So therefore, y is equal to x plus 8 is a point that passes through the point we needed to pass through, and is also perpendicular to -x plus 4, as they have negative reciprocal slopes. Okay, so step two is to find the intersection of the two lines. Now, why would we want to find the intersection of the lines? Well, we need to find what the other point is, right? We're measuring a distance from the point -6, 2 that we were given to the line, right? To the other line. And so we need to know, okay, where do these two lines, the line that goes from there through our other line in a perpendicular way, and the first line we were given, where do those two meet? Because where they meet is the other point that we're going to use later with the distance formula in order to find the distance. And so let's do that. Let's find the intersection between y equals x plus 8 and y equals -x plus 4, was it? Yep, plus 4. So that means if we use substitution, we're going to get x plus 8 equals -x plus 4. That means that 2x plus 8 is equal to 4 if we add x to both sides. If we subtract 4 from both sides, we get that 2x is equal to 4, which means x is equal to 2. And then if we sub that back into the first equation, y equals x plus 8, we get y, or sorry, my apologies, this should be -4. And so we should have gotten -2 there, my mistake there. So then we're going to get y is equal to -2 plus 8, which means y is equal to 6. And so the other point is -2, 6. That's where the lines intersect. And so now the step 3 is to find the distance between those 2 points. Find the distance between 2 points. And to do this, we're going to use the distance formula. Back in Unit 1, we did a whole session about the distance formula. And actually, same with Step 1. There was a whole video, but in this chapter, in this unit, Unit 3, about finding a line perpendicular to another line passing through another point. So this is something we've done previously. Step 2, we haven't as of yet covered this specifically. There is a video on step 2 specifically as a question from Algebra 1, but not from geometry though. But anyways, we're going to find the distance between the 2 points, between -6, 2 and -2, 6. So let's do that. The distance is going to be equal to the square root of the change in y, or the change in x rather, squared, plus the change in y squared, which is going to be -4 squared plus -4 squared, which is root 32. And that can be simplified to 4 root 2. And so therefore, the shortest distance between the 2 points would be 4 root 2. All right.